All right, let's get into it. Today, we're going to build a blueprint for creating really modern applications on AWS. We're talking about everything from the backend services that you use every single day, all the way up to the complex machine learning operations that are powering all the AI we see. It can really feel like magic, can it? How does a simple script, just a few lines of code, turn into a massive, global, AI-powered service? Well, it's not magic, it's engineering. And any great engineering project always starts with a solid blueprint. And that is exactly what we're going to do here. We're going to build that blueprint piece by piece. We'll start at the very bottom with the cloud foundation and build our system up one logical layer at a time. Okay, let's dive in. So, our first layer is the foundation. Before you can build anything, you need your materials, right? This is our AWS toolkit. These are the fundamental services that absolutely everything else is going to rest on. Think of these services as your concrete, your steel, your wiring. They are the complete non-negotiables for building anything robust and serious in the cloud. So let's take a look at the core pieces. Okay, so right off the bat, you have your first really big decision. How are you going to manage your application containers? ECS is Amazon's own solution. It's simpler and it's super tightly integrated with everything else on AWS. EKS, on the other hand, gives you the full power and flexibility of Kubernetes, which is the industry standard. This choice between simplicity and control, it really sets the tone for your entire strategy. Next up, we need a home for our data, Amazon RDS. And the most important word here is managed. It means AWS handles all the boring stuff, the maintenance, the patching, the backups. That frees up your team to actually focus on building your app, not just babysitting a database. And this really shows you why RDS is such a big deal. The automated backups, that protects your data. Read replicas, they help you scale out to handle huge amounts of traffic. And the failover mechanisms keep your application online even if a database instance goes down. It's a complete, resilient system right out of the box. And to round out our toolkit, you've got S3, which is basically your infinite hard drive for any kind of data or file. Then there's Lambda, which lets you run code without ever thinking about servers. And finally, CloudWatch and X-Ray. These are your eyes and ears, giving you that crucial monitoring and observability into what's actually happening. So we have our materials. Now we need the master plan. In Layer 2, we stop building things by hand, and we start automating our entire infrastructure with code. Infrastructure as code, or IAC, is an absolute game changer. Instead of clicking around in a web console, you literally define your servers and your databases in a code file. This makes your whole setup repeatable, version-controlled, and perfectly consistent every single time to deploy it. When it comes to ISC on AWS, there are two main players. CloudFormation is the AWS native tool, so you get seamless integration. Terraform is more of a multi-cloud powerhouse. It can manage other providers too. So the choice really comes down to, do you want deep AWS integration, or do you need that multi-cloud flexibility? A really solid IIC workflow pretty much always follows these 5 steps. You define your infrastructure in code, you version it in Git, you test it, and then you automatically deploy it. But that final step, number 5, detect, that's a really critical one. It's all about monitoring for something called drift. So what is this drift we're talking about? Well, it happens when your live environment gets changed manually, maybe by an engineer trying to fix something in a hurry, and it no longer matches what's defined in your code. Drift detection is all about finding those discrepancies so you can enforce your code as the one and only source of truth. Okay, so our foundation is laid and our automated master plan is in place. Now it's time to build the actual structure, our applications, how we package them up, and the databases that are going to power them. Pretty much all modern applications are packaged up in Docker containers these days, but following best practices is absolutely critical. Optimized images start up way faster, multi-stage builds make your app more secure, and constantly scanning for vulnerabilities keeps you safe from attacks. When it comes to the database itself, PostgreSQL is a hugely popular and powerful choice. It's open source, it's famous for being incredibly reliable, and it's just packed with advanced features that are perfect for modern apps. So what makes it so special? Well, you get things like advanced indexing, which makes your queries incredibly fast. It has native support for JSON-B, so you can store flexible data without any hassle. And tools like partitioning and CTEs give you the power you need to handle massive data sets and write really clean, complex queries. Now, for our AI systems, we need a special kind of tool, a vector database. You see, AI models convert concepts like text or images into these long strings of numbers called vectors. Vector databases are purpose-built to store and search through millions of these vectors based on their meaning, which is what powers modern semantic search. Okay, let's move up to our final layer, the really cool part, the smart systems. It's time to install the specialized MLOps layer that's going to bring our machine learning models to life. And this is probably the most important thing to understand about MLOps. It is not a tool you can just buy. It's a set of practices, a discipline. It's all about combining the reliability of DevOps with the unique, messy challenges of machine learning so you can manage a model's entire lifecycle reliably. And if you want to implement those practices on AWS, you're probably going to use SageMaker. Think of it as a fully managed platform that just streamlines that entire ML lifecycle. From labeling data and training models all the way to deploying and monitoring them, it handles a lot of the heavy lifting for you. Now, with large language models, monitoring gets really specialized. Of course, you track latency. How fast is the model? You also have to detect drift. Is the model's behavior changing or getting worse? And critically, you have to monitor for hallucinations. That's when the model just confidently makes up incorrect information. So if we take a step back and look at our whole blueprint, it's really built on 3 core principles. 1, automate absolutely everything. 2, build with modular components like containers and services. And 3, observe continuously, because you can't fix what you can't see. These are really the pillars of any modern system. And that's our 4-layer blueprint. But technology, it never stands still. As these new tools let us build more and more autonomous AI agents, it really makes you ask the question you see here. What is the next layer of our blueprint going to look like? That's the challenge for the next generation of builders. Thanks for watching.